How are you, everyone? Let's look at this question. This question is falling under Circle Theorem. So we have the diagram. A, B, C, and D are points on the circumference of the circle. So we have A, B, C, and D. These are points on the circle. So we call it a point on the circumference of the circle with center O. So O is the center. So once you see the center O, meaning there's a radius. Any distance from the center to the circumference is a radius. From here also up to there is a radius. From here, any center from the circumference is a radius. Then such that the angle OBC is 40 degrees. You have O here, B here, C. The angle at B here is 40 degrees. Then you have also an angle DCA. It is 32. D here, C here, A here is 32 degrees. And TR is a tangent to a circle at B. So this TR is a tangent to a circle at B. Remember, a tangent simply means a line touching a circle at one point. Then there's AC is the diameter. AC is the diameter. From A to C is the diameter. Means that this one, it is a line cutting a circle into semicircle, or in short, into half circle. Then there's BD is intersect at X. This called BD. BD intersect at what? X. Okay. So find the angle ABT. So we are going to use the properties of the circle. Find the angle ABT. So we have A here, B here, T. So looking for this angle. So to find this angle, we are going to use the circle properties, which states that angles on alternate segments are the same. So if you have a circle, example, you have a tangent and there's a triangle inside. This angle here is same as the angle here. This angle here is same as the angle. These two angles are angles on alternate segments. As long as there's a triangle touching on the circles and there's a tangent, this angle is same as that angle. So simply means that this angle here, what you're looking for, ABT, is same as this is a triangle here, following this property. It's same as this angle here. You have seen? Same as this angle, because this triangle and that angle are angles on alternate segment. So the easiest way is to know this angle. So how can you find this angle? We know that this is a radius and that's a radius, meaning this type is an isosceles triangle, meaning that the base angle are the same. Since here is 40, also here will be what? 40. So if this is 40, also the angle here is 40. So the angle here, it is 40 degrees, like that, without wasting time. Following this property, we move. We go to the next question. Find the angle OAB, this angle here. To find the angle of OAB is very simple. We know that this is a triangle. This is a triangle. The sum of interior angles in a triangle, this angle at A plus the angle at here, which is 40, plus this O angle here is equal to 180. And we know that this angle is 90 degrees because this angle ABC, it is the angle formed in a semicircle. The angle forms in a semicircle. So this ABC, it is 90. So we're going to say, angle A, I'll use a small letter, plus this is this O angle ABC is 90, plus 40 is equal to 180. Then what do we do? We're going to say A is equal to 180. I'll add 90 plus 40. We are going to have 130. We're going to have 130. 130 to go this side be minus 130. So angle A, it is 180 minus 130 simply means we have 50 degrees. So means this angle is what? 50, because we add 40 plus this is 90, all of it, because this angle is formed on a diameter on the semicircle. 40 plus 90 is 130. 130 from 180, we get 50. So this angle here, it is 50 degrees without wasting time. So these questions are very simple. Just remember to follow so that I can and subscribe to our YouTube channel so that you can get a notification. For tuitions, I'll put the number, you can simply WhatsApp. Okay, so let's look at the last question. The last question is saying, find the angle CXB. CX, C here, X is here, and B. You're looking for this angle here, CXB. the angle CXB. CXB. This angle here. Looking for the angle CX B. How can you find the angle at CXB? CX To find the angle at CXB, we can easily find the angle at X. Once you find the angle at X, this is a straight line. CAB. We find the angle at X. When we find the angle at X, it is a straight line. A straight line adds up to 180. And now, how can you find the angle at here? We know that a triangle adds up to 180. This is the angle at the circumference is twice the angle at the center. When you look at this property, you have this one. If this angle is 20, this one is 40. The angle at the circumference is twice the angle at the center. So let's find first the angle here. Once you find the angle here, you can find the angle X. Once you find the angle X, you can easily find the angle CXB, like that. Okay, so here, this is 40, this is 40. 40 plus 40, it is 80. 80 from 180, this is 100. If this is 100, half of 100, it will give you the angle here, which is 50. If this is 50, also there's this property to say that angles in the same segment are equal. So if this is 50, also this is 50. Now to find this angle X, we know that this is a triangle. This is what? A triangle. 50 plus 32, the answer you get subtract from 180, we have angle X. So you're going to say X plus 50 plus what? 32 equal to 180. So you're going to have X is equal to 180. 50 plus 32, you're going to have minus 82. When you subtract, what is 180 minus 82? We are giving us 98. Give us 98. So this is 98. If this is 98, to find the angle here at CXB, we just say 180 is a straight line minus 98. So CXB, the answer is 82 degrees. So please, if you need tuitions, you can kindly WhatsApp on this number 07711106684. You can WhatsApp this line or you can call on this line 0777257 508. Thank you.